Good evening, sir. It's me again. It's my final video. I want to talk about to determine the instantaneous wave of change with the idea of a limit, and find the slope of a tangent by using the secant line. First, when we want to determine the instantaneous wave of change at a point, we usually draw a tangent line first, because the slope of the tangent line is the instantaneous wave of change at this point. As we know, the tangent line is going in the same direction as the curve, and is thus the best straight line approximation to the curve at the point. So it is obvious that it's the tangent line at point A. And when we work in advanced function, we usually use the secant line to determine the slope of the tangent. Right now, I have an interval from the x value from a to a plus h. The absolute value of h is the distance of the first point A to the second point. So, when the h greater than 0, it will be on the right side of point A, which is the following interval. When the h is less than 0, it will be on the left side of point A, which is the preceding interval. Because the domain of the curve part is from negative infinity to 0. So, the preceding interval and the following interval both can work to determine a secant line. And two secant lines can work to estimate the tangent line. Now we have the secant line, so we can write the secant line in formula, the slope of the secant line in formula. Because in this investigation, the purpose is to determine the slope of the tangent at point A. So, when we want to determine the slope of the tangent, we can use the slope of the secant to deter that. When the x value, the second point, a plus h, approach the point A, the x value approach to point A, the distance between these 2 points is getting smaller and smaller. These 2 points are going closer and closer. So, the interval approach to 0 and the absolute value of h either approach to 0. So, we can write the tangent, the slope of the tangent in formula right now. Because the distance between 2 points tend to 0, so the slope of the secant will tend to the slope of the tangent at point A. Also, there have some situation we can't use the idea of limit because it doesn't exist. Let's focus on x equal to 0. As we can see, from the left side, the instantaneous wave or change approach to 0, but from the right side, the instantaneous wave change around the 0 is approaching to the slope of this linear. It is obvious that these two instantaneous wave or change can approach to each other. So, in this situation, the left and the right limits of the formula exist, but two side limit does not exist.